Okay, so first example, if a bag contained 4 red, 3 black, 2 orange, and 4 blue girls, what is the probability Greg drew a red marble, did not replace it, then drew an orange marble? So how many total marbles does he have? 13. So he's got 13 total marbles. So we want to have our first ratio. Our first probability is going to be the red marbles. So how many red marbles out of the total? There's 4 red, right? So we're comparing the amount to the total. We added all the marbles up, and out of those, there's only 4 red. So if he does not replace it back in the bag, how many total marbles do we have after that? 12. We should have 1 less than our total because he didn't put it back in the bag. So now we should have 12. And that was if he drew an orange marble next. So how many orange do we have?
3.
Orange marbles, how many? 2. Okay. Then what we want to do is we can multiply these 2 together. Multiply across. And it may be easier, this 2 over 12, we can make this smaller so it's easier on us.
1/6.
So 1/6. So 4/13 times 1/6. Four over 78. And I bet we could make that smaller. What do you think? Could we divide by 2?
39.
So 2 over 39. So that's my probability. The probability of a red marble not replacing it, and then an orange marble out of what's left. So 2/39. Make sure we're writing this down, girls. Next one, donuts are provided to students at morning student council meetings if the box contains 3 chocolate, 5 glazed, and 4 sprinkle donuts. What's the probability of Sam selecting a chocolate donut without looking? So how many total donuts does he have to choose from? Well, we can count them. There's 3, 5, 4.
12.
Good. There's 12 total donuts. And the amount, the top number, the one that he's picking randomly, was the chocolate donuts. How many chocolate donuts do we have? 3. So can I make this any smaller?
Yes.
Yes.
1/4.
So the probability of him grabbing a chocolate donut without even looking in the box is 1 out of 4. So 1 out of 4 times he's going to grab chocolate.
I like chocolate.
I do too, actually. It's my fave. Okay. Okay, so 2 more last on this side. Carrie is performing an experiment in math class. She tosses a coin, which is how many sides on a coin?
2.
Just 2 on a coin, heads and tails, and spins an equally divided 4-color spinner, red, yellow, blue, and green. What's the probability of her spinning a red and the coin landing on tails? So we want to make 2 different ratios like we did on that first example. We want the total and we want the amount. So the first time, the probability of her spinning a red. So just looking at the spinner, yeah, there's going to be 1 red on that 4-color spinner. So the total was 4, just red, it would be 1. And then the probability of landing on tails in a coin. Good. There's 2 options, heads and tails. Tails is one of those. Multiply those 2 together. Just multiply across. So 1 times 1 is 1, 4 times 2 is 8. So 1/8.
I remember when we were first starting to learn how to multiply and we didn't have something for it.
almost done. Last one. Jake is selecting an outfit for school. He has 3 shirts, 2 sweatshirts, 2 pair of wind pants, and 3 jeans. How many combinations of tops and bottoms does he have to choose from?
10.
So this is a little bit different. We can make those ratios like we've done before, but we're really just wanting to multiply these numbers together. 3 t-shirts, 2 sweatshirts, 2 pair of wind pants, and 3 jeans. So we've got 3, good, times 2, times 2, times 3. Good, so 3 times 2 is 6. Or you could look at it as,
36.
yeah, you could look at it as 6 times 6. So there's 36 possible combinations. If it ever asks just how many possible combinations, you can always do that. Multiply all of those together. You don't necessarily have to make those ratios.